Hello student, very good morning. Myself Durga Shankar Panda. Today we will discuss about the paper Refrigeration and Air Conditioning, and the chapter is Psychrometry, and particularly for psychrometry processes. So today's discussion outline is the different psychrometry process, starting from sensible heating, then sensible cooling, humidification, dehumidification, cooling and humidification, cooling and dehumidifications, heating and humidifications, and heating and dehumidifications. So before discussing the different psychrometry processes, we should identify different terms of psychrometry in psychrometry chart. This one is a psychrometry chart. The vertical lines, these are the vertical lines, it indicates a dry wall temperature. Suppose here, starting from minus 10 degree, minus 5, then 0, 5, 10 and up to 55 degree Celsius dry wall temperature. And the horizontal line, this horizontal line is known as specific humidity line. It is started from 0.001 kg per kg of dry air or 1 gram per kg of dry air, and it is started from 0.001 kg to up to 0.033 kg per kg of dry air. If we will convert, it is 33 gram per kg of dry air. And here is the specific enthalpy. It is started, suppose 5, 10, 15 and up to 115 kilojoule per kg of dry air. And the curve line, this is the curve line, it indicates the relative humidity, that is in percentage, 10%, 20%, 30%, 40% and up to it is 198%, then 100%, the relative humidity. And the inclined line, it indicates a wet wall temperature. Suppose wet wall temperature, it is started from minus 10, minus 5, 0, 5 and up to the wet wall temperature 30-35 degree Celsius wet wall temperature. And this line indicates the specific volume, that is meter cube per kg. It is started, suppose 0.75 meter cube per kg of dry air, 0.80, 0.85, 0.90 meter cube per kg of dry air, the specific volume. Then in our psychrometry processes, so we have to identify two major parameters, that is dry wall temperature and specific humidity. Here it is clearly shown, this dark line, vertical dark line is indicating the dry wall temperature of air. Suppose it is minus 10, 5, 0, minus 10, 5, 0, 5, 10 and up to 55 degree. And this horizontal line clearly indicates the specific humidity 0.005, 0.010, 0.015, 0.020. The first process, suppose the sensible heating, suppose this is the original state of point, the state of air. If it move towards right directions, then it is sensible heating at constant specific humidity. If the process is used to increase the dry wall temperature of air, then it is sensible heating. In the reverse direction, if keeping the specific humidity constant or same specific humidity, if we reduce the dry bulb temperature, then it is sensible cooling. Suppose this is the starting point of the state of air, and gradually after the process the temperature reduce. The dry bulb temperature here is more than here, the second state, then it is cooling, that is sensible cooling. The same specific humidity, if the dry bulb temperature is reducing, then it is sensible cooling. At same dry bulb temperature, if we use the process, psychrometric process, to increase the moisture or specific humidity of the air, then it is humidification. So here is the same dry bulb temperature, suppose initial state of air, and after the process this is the final state of air, that specific humidity increased, and if the keeping the dry bulb temperature constant, increasing the specific humidity, then it is humidification. The reverse way it is, suppose same dry bulb temperature, if you reduce the specific humidity or moisture of the air, then it is dehumidification. It follows the bottom line. Suppose this is the initial state of the air and this is the final state of the air, that means decreasing the specific humidity at same dry bulb temperatures, keeping the dry bulb temperature constant, reducing the specific humidity, then it is dehumidification. And combination of two process, it is another four type of process, heating and humidifications. We are using the process to increase the dry bulb temperature, simultaneously increase the humidity. Suppose this is the initial state and this slope line, suppose towards the northeast. This slope line, suppose towards the northeast, it is heating and humidification. At that point, initial point, the temperature of dry bulb temperature, and the final state, definitely it is increase the dry bulb temperature, and at the same the specific humidity at the initial stage and the final state also increasing the specific humidity. So it is heating and humidifications. And towards north and west, it is cooling and humidifications. The dry bulb temperature reducing and humidity increasing, that means it is cooling and humidifications. And towards south and west, it is cooling and dehumidifications. Both the temperature, dry bulb temperature also decrease and humidity also decrease, then it is cooling and dehumidifications. And towards southeast, it is heating. Towards southeast, it is heating and dehumidification. As it is dry bulb temperature increase, that means heating, and humidity decrease, but that's why it is heating and dehumidifications. If we discuss about the sensible heating, the heating of air without any change in its specific humidity. The sensible heating, it says, heating of air without change in specific humidity is known as sensible heating. Let air at temperature TD1 passes over a heating coil of temperature TD3, then the air we receive the increased dry bulb temperature, and the process is known as sensible heating. And this graph shows 1 to 2. This is the initial state of air 1 and this is the final state of air 2, that is sensible heating. Without changing specific humidity, increase the dry bulb temperature, that is sensible heating. Then sensible cooling without changing the specific humidity, decrease the dry bulb temperature is known as sensible cooling. Let's say we use cooling coil, the temperature of cooling coil TD3 and the initial air, the temperature of dry bulb temperature of air TD1 pass through the cooling coil. Let's say the temperature of cooling coil TD3, and the process 1 to 3 is sensible cooling, keeping the specific humidity, same specific humidity. Here also the specific humidity in between 1 and 3, in between there is many space, the humidity, specific humidity is same. Also at point also the same specific humidity, but decreasing the dry bulb temperature at initial stage of air 1 and final state suppose 3, then decreasing the dry bulb temperature. Sensible cooling. The next one is humidification and dehumidification. So addition of moisture to the air without changing its dry bulb temperature is known as humidification. The moisture addition is there. We have to add some amount of moisture in the air without changing its dry bulb temperature. Then it is humidification. If we extract or remove some amount of moisture without changing its dry bulb temperature, then it is dehumidification. Similarly, removal of moisture from the air without changing its dry bulb temperature is known as dehumidification. So process 1 to 4, it is dehumidification without changing its dry bulb temperature. Thus, it is vertical line means same dry bulb temperature from initial state 1 to final state 4. It is decreasing the specific humidity. The removal process takes place, removal of moisture from air, and this is the 1 initial state of air and 4 is the final state of air. It is dehumidification. And process 1 to 5 without changing its dry bulb, increasing humidity. That means we are adding some amount of moisture to the air. Then it is humidification without changing its dry bulb temperature. If we adding some amount of moisture in the air, then it is humidification. So now we'll discuss about sensible heat factor. What is sensible heat factor? It is the ratio of sensible heat to the total heat. So mathematically sensible heat factor is equal to, it is symbolically it is represent SHF, sensible heat factor, that equal to sensible heat by total heat. So again sensible heat, it is SH divided by sensible heat plus latent heat. The total heat, it is the sum of sensible heat plus latent heat. So thank you. Next we will discuss rest part of the psychrometry process.